the language in the files that you would create. So where would you use something like Docker Compose? So an example would be if you are running an Apache server with MySQL database and you need to create additional containers to run additional services without the need to start each one separately. And this is where you would write a set of files using Docker Compose to be able to help balance out that demand. So let's now look at Docker Swarm. So Docker Swarm is a service that allows you to be able to control multiple Docker environments within a single platform. So what you actually are looking at doing is within your Docker Swarm is we're treating each node as a Docker daemon, and we're actually having an API that's interacting with each of those nodes. There are two types of node that you're going to be getting comfortable working with. One is the manager node and the second is the worker node. And as you'd expect, the manager node is the one sending out the instructions to all of the worker nodes. But there is a two-way communication that is happening. The communication allows for the manager node to be able to manage the instructions and then listen to and receive updates from the worker node. So if anything happens within this environment, the manager node can react and adjust the architecture of the worker node so it's always in sync. It was really great for large scaled environments. So finally, let's go through what are some of the basic commands you would use within Docker. And once we've gone through all these basic commands, we'll actually show you a demo of how you'd actually use them as well. So if we're going to go in, probably the first command is to install Docker. And so if you have yum installed, you just do yum install Docker and you'll install Docker onto your computer. To start the Docker daemon, as you want to do systemctl start Docker. The command to remove a Docker image is docker rmi and then the image ID itself. And that's not the image name, that's the actual alphanumeric ID number that you want to grab. The command line to download a new image is docker pull and then the name of the image you'd want to pull. And by default, you're going to be pulling from the Docker default registry that will then connect to your Docker daemon and download the images from that registry. The command line to run an image is docker run and then the image ID. And then we have the, if we wanted to pull specifically from Docker Hub, then we would have docker pull and then the image name and colon its tag. To build an image from a Docker file, you would do docker build -t and then the image name and colon tag. To shut down the container, you would do docker stop container ID. The access for running a container is docker exec it container ID bash. So we've gone through all the different commands, but let's actually see how they would actually look, and we're going to go ahead and do a demo. So welcome to this demo where we're going to go ahead and put together all of the different commands that we have outlined in the presentation for Docker. First is just to list all of the Docker images that we have. So we do sudo docker images and we enter in our password. And this will now list out the images that we've created already, and we have 3 images there. So let's go ahead and pull a Docker image. So to do that, we'll go ahead and type sudo docker, and actually we don't want to do image, we want to select pull, and then the name of the image that we want to pull, which is going to be MySQL. And by default, this is actually going to go ahead and use the latest MySQL command, MySQL image that we have. So it's now going to go ahead and pull this image. It's going to take a few minutes depending on your internet connection speed. It's kind of a large file that has to be downloaded, so we'll just wait for that to download. You can see the others have completed. Just waiting for this last file to download. Almost there. Once that's done, what we're going to go ahead and do is we'll actually run the Docker container and create the new container using the image that we just downloaded, but we have to wait for this to download first. Alright, so the image has been pulled from Docker Hub. And let's go ahead and create the new Docker container. So we're going to do sudo docker run -d -p 0.0.0.0 :80 :80. And then we'll put in MySQL colon latest, so we have the latest version. And we have our new token, and that shows our new Docker container has been created. Now let's go ahead and see if the container is running. And we'll do sudo docker ps to list all the running containers. And what we see is that the container is not listed there, which means it's probably not running. So let's go ahead and list out all of the images that we have within Docker so we can see whether it's actually listed there. So we'll do ps-a. And yes, there we are. We can see that we do have our new container, MySQL latest, and it was created 36 seconds ago. But it's in the exited mode, so what we have to do is we have to change that status so it's actually running. So let's change that to running state. We'll do sudo docker run dash it dash dash name, and we can name it SL SQL MySQL /bin/bash, and that's now going to be in the root, and we'll exit out of that. And now if we list out the Docker containers, we should see it is now an active container. Sudo docker start, and then we'll start the saying it, and we should now see it. There we are. It's now in the running state. Excellent. And we can see that it was updated 6 seconds ago. We're going to go ahead and we're going to clear the screen. Okay, now what we want to do is remove the Docker container. So what we're going to do is check list of images that we have. And so sudo docker images. Here are the images that we have, and we have MySQL is listed. And what we want to do is delete MySQL. And to do that, we're going to type in sudo docker rm-f image MySQL. Run that command, and what we'll find is the image. There's no such image. Oh, okay. So what we actually have to do is we have to go and see that the image is now gone. It's been removed. Excellent. It's exactly what we wanted to see. And we can also delete an image by its image ID as well. However, if an image is running and active, we have to kill that image first. So we're going to go ahead and we're going to select the image ID. We'll copy that. And it's going to, we paste that. It won't be able to actually run correctly because the image is active. So what we have to do now is stop the image and then we can kill it. So it's in the running state. So we have to do, so we do sudo docker kill and kill SL, and that will kill the container. And now we'll see that the container has gone. And now we can delete the image. And that's going to be the image gone with the image ID. Ba-boom. Easy peasy. Okay, let's go ahead onto the next exercise, which is to, so here we are, we've listed all of the containers and they're all gone. So let's go on to the next exercise, the final exercise, which is to actually create a batch image. And we're going to do a batch HTTP image. So let's go ahead and write that out. So it's going to be docker run dash dit dash dash name white. That's going to be the name of this HTTP service dash p 8080:80 -v, open quotes, $pwd, close quotes, colon, /usr, /local, /apache2, /htdocs, /httpd, semicolon 2.4. We'll run that. Put in our password again. So what we see is the port is already being used. So let's go ahead and see which ports. Let's go see if we can change the port or see what ports are running. So let's do sudo images and see which ports are being used, because it's either the port or the name hasn't been put in correctly. So sudo docker images ps, sudo docker ps-a, and yep, there's port 80 there. So we'll clear the screen. So we're going to change the container name, because I think we actually have the wrong container name here. So let's go in and change that, and we'll paste that in, and voila. There we go. Now working, and we'll just double check and make sure everything's working correctly. So to do that, we'll go into our web browser, and we'll type in, as soon as Firefox opens up, type in localhost :8080, which was the port that we created. And there we are. It's a list of all the files which shows that the server is up and running.
This is Anjali from Simplilearn, and today we'll dive into a tutorial on the configuration management tool Chef. So if you look at the DevOps approach or the DevOps lifecycle, you will see that Chef falls under operations and deployment. Why should we use Chef? Well, consider a large company. Now this company caters to a large number of clients and provides n number of services or solutions. Of course, to get all of this done, they need a huge number of servers and a huge number of systems. Basically, they will have a huge infrastructure. Now, this infrastructure needs to be continuously configured and maintained. In fact, when you're dealing with an infrastructure that size, there's a good chance systems may be failing. And in the long run, as your company expands, new systems may even get added. So what do? Well, you could say the company has the best system administrator out there, but all by himself, could he possibly take care of an infrastructure that size? No, he can't. And that's where Chef comes in, because Chef automates this entire process. So what does Chef provide? Chef provides continuous deployment. So when you look at the market space today, you see how products and their updates are coming out in a matter of days. So it's very important that a company is able to deploy the product the minute it's ready, so that once it's out, it's not already obsolete. Chef also provides increased system robustness. As we saw, Chef can automate the infrastructure. But in spite of this automation, there's a good possibility that errors do creep in. Chef can detect all these bugs and remove them before deploying them into the real environment. Not only this, Chef also adapts to the cloud. We all know how today the services, tools, solutions, everything's revolving around the cloud. So Chef does really play along by making itself easily integratable with the cloud platform. So now that you know why to use Chef, let's look at what exactly is Chef. Chef is an open source tool developed by Opscode. Of course, there are paid versions of Chef, such as Chef Enterprise, but other than that, most of it is freely accessible. Chef is written in Ruby and Erlang. If you would have gone through any previous material on Chef, I'm sure you would have come across Ruby being related to Chef, but not Erlang. So this is why, because Ruby and Erlang are both used to build Chef, but when it comes to actually writing the codes in Chef, it's just Ruby. And these are the codes that's deployed onto your multiple servers and does the automatic configuration and maintenance. And this is why Chef is a configuration management tool. So I've used this term configuration management a couple of times. What exactly does this mean? Let's start with the definition of configuration management. Configuration management is a collection of engineering practices that provides a systematic way to manage entities for efficient deployment. So let's break this down. Configuration management basically is a collection of practices. And what are these practices for? These practices are for managing your entities, the entities which are required for efficient deployment. So what are these entities that you need for efficient deployment? They are code, infrastructure, and people. Code is basically the code the system administrators write for configuring your various systems. Infrastructure is the collection of your systems and your servers. And then finally, you have the teams that take care of this infrastructure. So codes need to be updated whenever your infrastructure needs a new configuration or some sort of updation in the operating system or the software versions. Your code needs to be updated at first. And as the requirements of the company change, the infrastructure's configuration needs to change. And finally, of course, the people need coordination. So if you have a team of system administrators and say person A makes some change to the code, person B, C, D, and so on need to be well aware when the change is made as to why it was made, what was the change made, and where exactly this change was made. So there are two types of configuration management. On our left, we have the push configuration. Here, the server that holds the files with instructions to configure your nodes pushes these files onto the node. So the complete control lies with the server. On your right side, we have the pull configuration. In case of pull configuration, the nodes poll against the server to first check if there's any change in the configurations required. If there is, the nodes themselves pull these configuration files. Chef follows pull configuration, and how it does this, we'll see further in our video. Another important term often used with Chef, infrastructure as code. So let's understand what this term infrastructure as code means through this small story. So here's Tim. Tim's a system administrator at a large company. Now he receives a task. He has to set up a server and he has to install 20 software applications over it. So he begins. He sets up the server, but then it hits him. It would take him the entire night to install 20 software applications. Wouldn't things have been much simpler if he just had a code to do so? Well, of course, codes do make things much simpler. Codes have a number of advantages. They're easily modifiable. So if today Tim is told we need MySQL installed on 20 systems, Tim simply writes a code to do so. And the very next day Tim is told, we changed our mind. We don't need MySQL. I think we'll just use Oracle. This does not bother Tim because now he just opens the file, he makes a few corrections in his code, and that should work just fine. Code is also testable. So if Tim had to write 10 commands to do something, and at his 10th command he realized the very first command he wrote, there was something not right there. Well, that would be quite tiresome, wouldn't it? With codes, however, you can test it even before running it, and all the bugs can be caught and corrected. Codes are also deployable. So they're easily deployable and they're deployable multiple times. So now that we saw the various advantages of having codes, let's see what infrastructure as code exactly is. Here's the definition. Infrastructure as code is a type of IT infrastructure where the operation team manages the code rather than a manual procedure. So infrastructure as a code allows the operations team to take care of a code which automatically performs various procedures rather than having to manually do those procedures. So with this feature, all your policies and your configurations are written as code. Let's now look at the various components of Chef. So our first component is the workstation. The workstation is the system where the system administrator sits. He or she creates the codes for configuring your nodes. Now these codes, which in case of Chef are written in Ruby, are called the recipes. And you'll have multiple number of recipes. So a collection of recipes is called a cookbook. Now these cookbooks are only created at the workstation, but they need to be stored at the server. So the knife is a command line tool. So it's basically a command that you will see us executing in one of our demos that shifts these cookbooks from the workstation over to the server. Our second component is the server. So server is like the middleman. It lies between your workstation and your nodes. And this is where all your cookbooks are stored. Because as you saw previously, the knife sends these cookbooks over from the workstation to the server. The server can be hosted locally, that's on your workstation itself, or it can be remote. So you can have your server at a different location. You can even have it on the cloud platform. And our final component, the node. So nodes are the systems that require the configuration. In a Chef architecture, you can have a number of nodes. Ohai is a service which is installed on your node, and it is responsible for collecting all the information regarding your current state of the node. This information is then sent over to the server to be compared against the configuration files and check if any new configuration is required. Chef Client is another such service on your node which is responsible for all the communications with the server. So whenever the node has a demand for a recipe, the Chef Client is responsible for communicating this demand to the server. Since you have a number of nodes in a Chef architecture, it's not necessary that each node is identical. So of course, every node can have a different configuration. Let's now have a look at the Chef architecture. So here we have a workstation, one server machine, and 2 nodes. You can have any number of nodes. First things first, the system administrator must create a recipe. So the recipes that are mentioned in our Chef architecture are just dummy recipes. We'll look into actual functioning recipes later in our demo. So you have 1 recipe, 2 recipes, 3 recipes, and a collection of recipes forms a cookbook. So guys, if you look at the recipe, in source you have simply learn 3.erb. ERB is the extension for your Ruby files. So the cookbooks are only created at the workstation. They now need to be sent over to the server where they are stored. And this is the task of the knife. Knife is a command line tool which is responsible for transferring all your cookbooks onto the server from the workstation. Here's the command for running your knife. Knife upload simply-db, where simply-db is the name of the cookbook. We then move on to our node machines. At our nodes, we run the Ohai service. The Ohai service will collect all information regarding the current state of your nodes and send it over to the Chef client. When you run the Chef client, these informations are sent over to the server and they are tested against the cookbooks. So if there is any discrepancy between the current state of your nodes and the cookbook, that is, if one of the nodes does not match the configurations required, the cookbook is then fetched from the server and executed at the node. This sets the node to the right state. There are various flavors of Chef. We'll quickly go through these. First, we have Chef Solo. With Chef Solo, there's no separate server, so your cookbooks are located on the node itself. Now, this kind of configuration is used only when you have just a single node to take care of. The next flavor is a Hosted Chef. With Hosted Chef, you still have your workstation and your node, but your server is now used as a service on the cloud. This really makes things simple because you don't have to set up a server yourself and it still performs all the functioning of a typical Chef. This is the configuration you will notice that we'll be using in our demo. Chef Client Server. With Chef Client Server, you have a workstation, you have server, and you have n number of nodes. Now, this is the traditional Chef architecture. This is the one we have used for all the explanations previously. And finally, we have Private Chef. Private Chef is also known as Enterprise Chef. In this case, your workstation, server, and node all are located within the enterprise infrastructure. This is the main difference between Chef Client Server and Private Chef. In case of Chef Client Server, all these 3 machines could be dispersed. The enterprise version of Chef also provides the liberty to add extra layers of security and other features. And we reach the final part of our video where we'll have the hands-on. So before we dive into our demo, let me just quickly give you an introduction to it. We'll be using 2 virtual boxes, both CentOS 7. One will be used as a workstation while the other will be a node. So we are just using one node to make things simple. The server will be used as a service on the cloud. Now these are the steps we'll be performing during our demo. We'll first download and install the Chef DK on our workstation. We then make an empty cookbook file and we'll write a recipe into it. We need to then set up the server. So as I mentioned earlier, server will be a service on the cloud. So you'll have to create a profile, but this will be completely free. We then link the workstation to the server and will upload the recipe to the server. The nodes will now download the cookbooks from the server and configure themselves. So now that you have some idea about what we'll be doing, let's move on to the actual demo. We begin our demo. Here's my Oracle VM VirtualBox Manager. I have two machines here. I've already created my workstation and node. Both of these are CentOS 7 machines. Just for you to differentiate, this is my terminal. And for my workstation, it's a black background with white text. And as of my node, it's a black background with green text. The first thing you do is you go to your workstation box and open a web browser. Search for Chef DK installation. Go to the first link, which is your Chef's official page, and under Red Hat Enterprise, because our system's a Red Hat system, select the link of the version that you're using. So I'm using CentOS 7, so my operating system version is 7, so I'll take this link. Now this is the link for downloading your Chef DK. You copy this link and go to your terminal. Guys, notice I'm in the home directory of my root user. So let's install our Chef DK. And it's getting installed. Now this will take some time because it's quite a large file. And Chef DK is downloaded. Next step, we need to install it. And this is the version of the Chef DK that we have downloaded. So type the same. Okay, so that's done. So now we need to make our recipes, and the recipes will exist within cookbooks. So first let's make a chef repository. So within that we'll have a folder for holding all our cookbooks, and within our cookbook we'll write our recipe. So we start with the directory for chef repository. Move into it. Create a folder called cookbooks, within which we'll store each of our cookbooks. Move into this folder. Okay, so we'll just check the contents here right now. So we have our Chef DK, we have a chef repo folder here, and let's check the contents of the chef repo. And this has cookbooks. Okay, so our first cookbook that we'll be making will be under this folder cookbooks. So let's move into cookbooks. We are in. Now we need to create our first cookbook. So the instruction for creating your first cookbook is chef generate cookbook and the name of your cookbook. So I'm just giving the name as sample. Yeah, so our cookbook sample is created. Now when you create your cookbook, you'll notice that a hierarchy is also automatically created. So let's just check the hierarchy of our cookbook. Let's move into sample, and tree is the command for checking the hierarchy. So here, as you can see, we have recipes, and under recipes we have default.rb. So we'll be editing this default.rb to create our recipe. Okay. So let's begin with that. Let's move into our recipes folder and open your default.rb. And here we are. So now we'll type in our code. So what's our recipe for? Our recipe is for installing the HTTPD package on our node, and then we'll also create a small index file where we'll just have a simple content such as welcome or something like that, just to check if our HTTPD is working fine. So let's begin typing the code here. Package HTTPD service HTTPD do. And what must be done with this package is that once it's installed, it needs to be enabled and it needs to be started. And so that's our first task. Our next task is creating our HTML file. So as you know, all your HTML files will follow this path name. And this is the content of your file. You have successfully configured your node. And that's it. That's our simple code. So our recipe is now ready. Save it and exit back to your terminal. Now what we need to do is that we need to configure our server. So go to your browser. On the search engine, type manage.chef.io. So as I mentioned earlier, we'll be using a server as a service on the cloud. So you'll enter your login page for the Chef server. Most of you may not have a profile already, so you go to click here to get started and fill in the details. It's just like creating an account on Facebook. So I already have my account. I've put in the credentials here. I'll just sign in. Now the first thing once you sign in is you'll get an option to create an organization. So all you have to do there is you gotta enter the name of your organization, and just below that there's another box for entering a short form of your organization. Now my organization name was Simply Learn and the short form was SLP123. So when you come to the administration tab under organization, you can see this organization name. Next step, click on this arrow and you got to download your starter kit. Okay, so once you click on starter kit, you'll come to this page where there's a button for download starter kit. So do download it. Save the file. So now come back to your terminal. So you come back to your terminal, and next what you need to do is you need to unzip your chefstarter.zip. So for that, first we'll move our chef starter to the root. So it's currently present under the downloads folder. Let's move it. So we have moved our chefstarter.zip. Now let's unzip it. First, let's just check the contents of our root directory right now. So we have our chef repository, chef repo folder that we created, the chef starter zip that we just moved, and of course the chef DK. So now we can unzip our chef starter kit. And that's done. So our next step, we got to move the chefstarters.zip file into our cookbooks, which lies inside the chef repository. This is done because we'll be executing our further commands to connect our workstation with the server from the cookbooks, because that is where our sample cookbook is. And that's moved. So now we'll run a knife command. So what knife does is that it uploads your recipes or your cookbooks onto the server. So here's the command for running your knife. Samples the name of the cookbook that you're uploading, and uploading sample 0.1.0 and uploading sample. Yeah, so our cookbook is uploaded. Now let's just check this at our server. How we do that is go back to your browser where you have opened your server. So there's no node here yet because we have not configured our node with the server, but we have configured our workstation with the server. And you see here our cookbooks uploaded, sample. So our workstation and our server are connected. So now we need to connect our node with the server. So first we move on to our node machine. We need to take the IP address of our node machine. So for the IP address, we'll just type ifconfig. Right, so this is your IP address. 192.168.2.190. Note this down somewhere, guys. Now that's done, go back to your workstation. I'll just keep it this way so I can see both. Okay. Go back to your workstation's terminal, but this time to connect our server with the node. So we have taken the IP of our node, and this is where we'll be using it. 192.168.2. The username, which is root in our case, and then enter the password, and then finally you enter your node name. So this is the name that will appear for this particular node on our server. I'm just giving it chef node. You can give it whatever you like. We'll just check the command knife bootstrap, the IP address, SSH user, our user, which is root, SSH password, the password for the root, and finally the node name. And the node's getting created. So once the node is connected to your server, we'll go back to our browser, open our server service on the cloud, and we'll check the node tab. So ideally, your node name should appear there. Great. So our node is added. Also, if you notice here, our Chef client service on the node has started running. So let's just check this with the server. Go to your nodes. And here we go. So Chef node, a CentOS 7 platform. This is our IP. So it's all done. So now we need to add a cookbook to the run list of this node. So come here, click on this arrow, edit run list. Here's sample. This is the cookbook that we want to run on our node. Put on the current run list. And here we have the run button. Just click on that. So this should have transferred our cookbook onto the node. Let's check that. Go to your node machine. Clear this. We need to be the root. Let's run the Chef client service. So we are running it once again because after it was started, we did add something to our run list. The changes in the run list is updated. So in 1 minute 56 seconds, our cookbook has run on our node. So the configuration changes should have been made. Let's check that. It's pretty simple. Just go to your browser. On the search engine, just type localhost. And here's our HTML page that we created on our workstation. Congrats, you configured your first node. And I really hope you did. So that is the end of our demo. We have successfully installed the HTTPD package on our node, and we have also executed a HTML file. We look into the tutorial on the configuration management tool Puppet. So let's begin. Why Puppet? So consider the scenario of an MNC. The MNC puts together the small team of system administrators. They're responsible for taking care of the infrastructure of this organization. Now this infrastructure could consist of data centers, server centers, and many such components. Fortunately for the MNC, they were doing extremely well. So the number of clients kept growing consistently, and with this came a boom in the infrastructure size. Now here is where the problem came in. With such a large infrastructure, the small team that they put together in no way could manage this. So what do? The solution seems pretty simple, right? Just increase the size of the team. Sure, we'll increase the size of the team. But when do you think we can put an upper limit on this size? When do we get to stabilize this team? So here is where Puppet comes in. With Puppet, a small team is enough to take care of this large infrastructure. This is because the data centers, server centers, all of them can be updated in a matter of seconds with Puppet. Entire load of doing so has now shifted from the team onto the tool. Not only this, with Puppet, if servers do fail, and there's a very high chance of servers failing when you're considering an organization the scale of an MNC, Puppet can instantly roll them back to their previous working states. And if that wasn't enough, Puppet also provides the capability to deploy servers on demand and enforce security on them. Now all of this is done through simple coding which is written in Ruby. We'll look at how Puppet works more. So now that we know why we should use Puppet, let's have a look at what exactly is Puppet. So first and foremost, Puppet is a configuration management tool, as I already mentioned in the beginning of this video. So this simply means that Puppet ensures that all your systems are maintained at a consistent state. So consider that you want to deploy a number of servers. Now you require these servers to be identical. If this task is given to a human, there's a very good chance that those systems will not be identical, or some of them may even fail. Humans are prone to errors, you cannot blame them. So Puppet ensures that all these servers are deployed on time and they are identical. Secondly, Puppet is also a deployment tool. This simply means that Puppet has the capability to deploy your applications, your services, softwares, all of this on your nodes automatically. And finally, Puppet implements infrastructure as code. Now, this term infrastructure as code is a very important one when it comes to the DevOps approach. You would have noticed this term being used in our previous video on Chef 2. If not, you can always click the top right corner to know more. So, what does this term infrastructure as code mean? Infrastructure as code simply means that all your policies, your tasks, your instructions, everything is written in coded format. So in case of Puppet specifically, all of this is written in the Ruby language. So now that we know what Puppet is, let's look into the Puppet architecture. So Puppet has a master-slave architecture. As you can see here, on the top we have the Puppet master and below we have the Puppet clients. So the Puppet master is the system where your system administrator sits. The clients are those systems which require configuration. You can have n number of clients connected to the Puppet master. So don't worry, we'll look into each of these components in detail. Firstly, we have the Puppet master. So the Puppet master is where the system administrator sits and he or she types in the codes here. So the codes are not only written in the system, but they are also stored here. And whenever the client requires these codes for their configuration, they simply request it. So manifest is the first subcomponent of the Puppet master. These are the actual files where the codes are written. So in case of Puppet, these are Ruby files. Modules tie manifest, templates, and files into a single unit. Now these codes dictate the instructions for performing various tasks on your client. The next component is templates. So if manifests are your code, templates are the data. So let me explain this to you with an example. Consider you want to create a file called index.html on one of your client machines. So what you do is, you write the code for creating this file in your manifest and the content of this file is written in your templates. Then you simply link them. But here's the thing, when you divide your code and data in this way, it's a very clean structure. So it's preferred to do it in this manner. Files are your static contents. So the files are basically sent to your client and they are simply downloaded at the client. There is no execution or compilation involved with your files. Now this is where files and templates are extremely different. Because with templates, they are never sent over to your client. The templates are simply read by the parser at the master itself. Modules ties the manifest templates and files into a single unit. So modules is not a separate component as such, it just provides a very clean hierarchy. This is the most important component of the Puppet master, CA, which stands for Certificate Authority. Now, as we will see later in this video, the Puppet master and the Puppet client communicate through an exchange of SSL certificates. So when the client sends over the certificate to the master, CA provides the master the authority to sign these certificates. The minute the master signs a certificate, the master is basically saying that yes, this client is registered with me and I agree to exchange data with this client. Our next component, Puppet client, of course these are the systems that require to be configured. Agent is a service installed on the client. The agent is solely responsible for all the communication between the master and the client. And finally, we have Factor. So Factor is responsible for collecting all the data about the present state of our clients and sending this data over to the Puppet master. At the master, this data is compared against the manifests, which are your code files, and then these manifests are sent over to the client depending upon the results of this comparison. So now that we had a look at the various components of Puppet, let's see how these work together. So we have a master and we have 3 clients. Now before any information can be transferred between the master and the client, it's important that these components recognize each other. Also, there needs to be an encrypted channel of communication between each pair of master and client. Now all the data which is transferred between the master and the client, it flows through this channel. So let's see how this entire procedure of recognizing each other works. The core of this procedure are the SSL certificates. SSL stands for Secure Socket Layer. Secure Socket Layer is a security protocol and it forms an encrypted channel between 2 components. What this encrypted channel ensures is that all the data that is passed through this channel is not accessible by any other system outside. So it provides complete security. Okay, so we will consider a very general scenario. We have a master and a client here. This is not the Puppet master or the Puppet client. They are just 2 systems and we are just going forward with master-slave architecture. So the client so far is not a client. It is just a system and we will refer to the system as system A. So system A sends over a client certificate to the master. Associated with this client certificate is the host name of system A. Now master goes through this certificate, it sees the host name, and then it decides whether it wants to form a communication link with the system A. If it does, it signs the certificate, and this signed certificate is sent back to system A. Now the system A is officially a client. The minute the master signed the client certificate, it said that yes, I am willing to exchange information with this system and I do take the system as one of my clients. So now that the system is officially a client, it can request for data from the master and the master will simply send over the data. Now we are here to talk about Puppet. So if this was a Puppet master and this was a Puppet client, then the first three stages will be the same. So the Puppet client sends over the certificate to the master signs the certificate, sends it back, and the client requests for data. Now by data here, of course, we mean the configuration data. Those are the manifest or even could be your files. So what happens after this request? After this request, the factor service which is present on your client collects all the information regarding the present state of your client. So this information could include the operating system that's installed on them, the various number of software present on them, the versions of these software. Now all this information is collected, it's called the fact, and it's sent over to the master. At the master, this information, that is the facts, is compared against the manifest. So why does the master do this? The master basically compares the facts against the manifest to know if what the manifest is about to perform is already performed on these systems. So if the manifest has some additional functionality, they are compiled into catalogs, and then these catalogs are sent over to the client. Now remember those agent services which existed in your clients? Here's where they come in. The agents take the catalog and execute them on the client. Once executed, these catalogs make the required changes on the client and a report is generated. This report is then sent back to the master. So the master keeps record of all the changes that's made in the system, and this comes very handy when one of the systems fail and it's required to be rolled back to its previous working state. So this entire procedure can be repeated n number of times and can be repeated at regular intervals. So if you have a scenario where a system needs to be configured every 30 minutes, what you can do is you can set your interval and automatically every 30 minutes your systems will be configured. And we reach the final and the most exciting part of our video, which is the hands-on. So today I'll be showing you how you can use Puppet to install Apache on one of your client machines. So we'll be using two machines here. We'll have a server and we'll have a node machine. The server is essentially your master. The node is your client. I'm just using the term server and node instead because I want to keep it very close to as they are used in the commands. Now both these machines are going to be CentOS 7 machines. And I have Oracle VM VirtualBox installed on my machine. So on that, I've simply created two virtual boxes, both CentOS 7 of course. So before we move on to the actual demo, I'll just take you through the various steps. So first we'll install the Puppet server on our server or master machine. We'll then start this server service. We then shift over to our node or the client machine and we'll install the Puppet agent service. We will then start this service too. And the minute you start the Puppet agent service, an SSL certificate is created. So this certificate will have the host name of your node attached to it. And this is how the master or the server will recognize this certificate and then it will sign this certificate. So once your master or the server signs the certificate, you can write your manifest. So the manifest are just the codes for configuration. And once that too is done, you shift back to your client or the node system and you run the agent service. So once you run the agent service, your manifest or your catalogs, because as you know, the manifests are compiled into catalogs, these are executed on your node and this will make the required changes. So that's how this entire process is going to work. Now let's move on to the actual demo. This is my Oracle VM VirtualBox Manager. The last two machines you see here are the ones we'll be using for this demo. The Puppet server is your Puppet master, Puppet client, of course, is the client. So let's just have a look at these two machines. This is my Puppet server. So just so you can differentiate, guys, The terminals have been set accordingly. Puppet server has a black background with white text, and Puppet client here has a black background with green text. So we'll move on to server machine or the master machine because that's the one we'll be working on first. So before we begin, we need to set the host name of our master to Puppet. So this is a very essential step in the configuration of Puppet. If you miss this out, there are quite a lot of other changes you'll have to make in certain files. So let's do this first. So that's the command to set the host name. The last word you see there, that's the new host name you want. Okay, so now we'll just check if our host name is set. So just type host name. And yeah, it's Puppet. So next, we will check the IP of this machine. So for that, you just type ifconfig. Enter. So this is your IP, guys, under ENP0S3, init's value, that is 192.168.2.183. Of course, the IP will differ for you guys, needless to say. So note that down somewhere because we'll require it when we are configuring our client. Okay, so now you want your Puppet server and your client to communicate. So for this, we need to remove certain firewalls. So the command for this is sudo, because we want the root permission, systemctl stop firewall d, and put in the password. Okay, so all your firewalls are removed. So the next step, now we start on with our Puppet process. So we download the Puppet labs at first. Now guys, ensure that your systems, your virtual boxes in this case, are connected to the net. Also, you won't be getting an IP if it's not for the first time. So here's the command to download the Puppet lab. Enter the password again. Okay, so the Puppet Labs is downloaded. Now you need to install this. So installation, guys, we will be installing the Puppet server on the master machine or the Puppet server machine. So this may take a while. So that took a while, so I just skipped to the last part where it's completed. The installation process is over. Now we need to make a small change in our system config Puppet server file. So let's just move to the file first. This file will open in VI editor. So this line here, it basically allocates memory for your Puppet server. Now you do not need 2 GB. So we are going to reduce this size. "512 MB should be enough. So guys, notice here I did not type the B, okay? So I just changed this to XMS 512M. Let's save that. Always remember to open this file using sudo. Otherwise, saving the changes you made could be quite troublesome. Okay, so now we can start our Puppet server service. We enable the service. Okay, so that's done. So basically our Puppet server service has started. It's running presently. So for a while we are done with the server machine. Let's move on to our client machine. Okay, first things first, we open our etc host file with sudo because you need to make a few changes and save it. Open this in the VI terminal. Okay guys, so here you have to add this one line at the end. Type in the IP for your Puppet server machine. Puppet dash master. So let's save this file. Now we'll move on to downloading Puppet Labs on our Puppet client. So the command is the same that we use for Puppet server. So Puppet Labs is downloaded. Now we need to install the Puppet agent service here. Again, this will also take some time. Puppet server is installed. Let me just clear this window. Now that our Puppet agent service is installed, we'll start this service. So I'll just type in the command for starting the Puppet agent service. As you can see here, ensure changed stop to running. So basically the service was not running before and now it's changed to the running state. And while we executed this command, not only did the service start running, but an SSL certificate was also created. So this certificate should have the host name of this machine, that's a Puppet client machine, attached to it. So let's just check what the host name of our machine is. That's localhost.localdomain. So our certificate should have this attached to it. So guys, the first time your client sends a certificate, the name of the certificate itself is usually the host name of the machine. So our certificate's name should be localhost.localdomain. We'll check this on our master system, and that's where we'll sign the certificate to. So first we list out all the certificates. In our case, since we have just one client and we just started the client, we should have technically just one certificate, and it will be so. Yeah, so this is our certificate, localhost.localdomain. We'll now sign the certificate. Okay, sorry about that. Just need to remove these brackets. Yeah, as you can see here, the certificate is signed. Signed certificate request. Here. So once the certificate is signed, the request for signing the certificate is removed. That's this line. Now that a certificate is signed, we can begin to write our manifest. So let's move into a manifest folder and we'll create a placeholder file. So we'll create a file called sample.pp. This is just a sample file. We won't be writing anything in this file as of now. So we are just checking here. We are just creating this file and then we'll go to our client machine and just check there if we can access this file from there. So now we'll move to our client machine. So let's test the connection. So as you can see here, it says applied catalog in 0.03 seconds. So our catalog is executed on our client machine. Now our catalog was just a placeholder basically. So the file that we created, which is sample.pp, had no content and we were just testing our client. Now let's go back to our master server, put some content into this file and see how the execution takes place. So we'll open our file sample.pp which we created earlier in the VI editor. Let's type our code here. So node, and then within the brackets we enter the host name of our client machine. So this ensures that our manifest is executed on this particular machine. Now the Apache service package on CentOS is called the HTTPD. So this line that I just typed in is the action. It will ensure that the HTTPD package is installed on your client. And that's it. So this is our code. We'll save it. Now let's go back to our client machine and test it. So this is our client machine. And our catalogs applied on the client. So I just cleared the screen. Now we'll start the Apache service. Okay, so how do we see if it's running? We just need to go to our browser and at localhost, you must have the testing page for your Apache. So we type localhost, enter. And yeah, this is the testing page for Apache. So as you can see, we have successfully used Puppet to install the Apache service on our Puppet client. And this is the end of our demo. Ansible is currently the most trending and popular configuration management tool, and it's used mostly under the DevOps approach. So let's begin. Why should you use Ansible? Let's consider a scenario of an organization where Sam is a system administrator. Sam is responsible for the company's infrastructure. A company's infrastructure basically consists of all its systems. This could include your web servers, your database servers, the various repositories, and so on. So as a system administrator, Sam needs to ensure that all the systems are running the updated versions of the software. Now, when you consider a handful of systems, this seems like a pretty simple task. Sam can simply go from system to system and perform the configurations required. But that is not the case with an organization, is it? An organization has a very large infrastructure. It could have hundreds and thousands of systems. So here is where Sam's work gets really difficult. Not only does it get tougher, Sam has to move from system to system, performing the same task over and over again. This makes Sam bored. Not just that, repeating the same task leaves no space for innovation. And without any ideas or innovation, how does the system grow? And the worst of it all is manual labor is prone to errors. So what does Sam do? Well, here is where Ansible comes in use. With Ansible, Sam can write simple codes that are deployed onto all the systems and configure them to the correct states. So now that we know why we should use Ansible, let's look at what exactly is Ansible. Ansible is an IT engine that automates the following tasks. So first we have orchestration. Orchestration basically means bringing together of multiple applications and ensuring an order in which these are executed. So for example, if you consider a web page that you require to host, this web page stores all its values that it takes from the user into a database. So the first thing you must do is ensure that the system has a database manager, and only then do you host your web page. So this kind of an order is very crucial to ensure that things work right. Next, Ansible automates configuration management. So configuration management simply means that all the systems are maintained at a consistent desired state. Other tools that automate configuration management include Puppet and Chef. And finally, Ansible automates deployment. Deployment simply means the deploying of application onto your servers of different environments. So if you have to deploy an application on 10 systems with different environments, you don't have to manually do this anymore because Ansible automates it for you. In fact, Ansible can also ensure that these applications or the code are deployed at a certain time or after regular intervals. Now that we know what exactly Ansible is, let's look at Ansible's architecture. Ansible has two main components. You have the local machine and you have your node or the client machine. So the local machine is where the system administrator sits. He or she installs Ansible here. And on the other end, you have your node or the client systems. So in case of Ansible, there's no supporting software installed here. These are just the systems that require to be configured and they are completely controlled by the local machine. At your local machine, you also have a module. A module is a collection of your configuration files. And in case of Ansible, these configuration files are called playbooks. Playbooks are written in YAML. YAML stands for YAML ain't a markup language. And it is honestly the easiest language to understand and learn since it's so close to English. We also have the inventory. The inventory is a file where you have all your nodes that require configuration mentioned. And based on the kind of configuration they require, they're also grouped together. So later in the demo, we'll have a look at how the playbook and the inventory is written, and that will probably make it clearer. So of course, the local machine needs to communicate with the client. And how is this done? This is done through SSH. SSH is your secure shell, which basically provides a protected communication in an unprotected environment. Okay, these components of Ansible. Now, how does Ansible exactly work? You have your local machine on one end. This is where you install Ansible. If you have gone through any previous material on Ansible, you would have come across the term agentless often being associated with this tool. So this is what agentless means. You're installing Ansible only on your local machine and there's no supporting software or plugin being installed on your clients. This means that you have no agent on the other end. The local machine has complete control and hence the term agentless. Another term that you would come across with Ansible is push configuration. So since the local machine has complete control here, it pushes the playbooks onto the nodes and thus it's called a push configuration tool. Now the playbooks and the inventory are written at the local machine and the local machine connects with the nodes through the SSH client. This step here is optional but it's always recommended to do so. It's where the facts are collected. So facts are basically the current state of the node. Now all this is collected from the node and sent to the local machine. So when the playbook is executed, the task mentioned in the playbook is compared against the current status of the node and only the changes that are required to be made further are made. And once the playbooks are executed, your nodes are configured to the desired states. So as I mentioned before, Ansible is currently the most trending tool in the market under the configuration management umbrella. So let's have a look at the various benefits of Ansible which gives it this position. Well, Ansible is agentless, it's efficient, it's flexible, simple, idempotent, and provides automated reporting. How does it do all this? Let's have a look at that. Agentless, as I already mentioned before, you require no supporting software or plugin installed on your node or the client system. So the master has complete control. And automatically this means that Ansible is more efficient because now we have more space in our client and node systems for other resources and we can get Ansible up and running real quick. Ansible is also flexible. So an infrastructure is prone to change very often and Ansible takes no amount of time to adjust to these changes. Ansible cannot get any simpler with your playbooks written in a language such as YAML, which is as close to English as you can possibly get. Idempotent basically means that if you have a playbook which needs to be run n number of systems, it would have the same effect on all of these systems without any side effect. And finally, we have automated reporting. So in case of Ansible, your playbook has a number of tasks and all these tasks are named. So whenever you run or execute your playbook, it gives a report on which tasks ran successfully, which failed, which clients were not reachable, and so on. All this information is very crucial when you're dealing with a very large infrastructure. And finally, we reach the most exciting part of our tutorial, the hands-on. Before we move on to the actual hands-on, let me just brief you through what exactly we'll be doing. So I'll be hosting two virtual boxes, both CentOS 7 operating systems. One would be my local machine and other my node or the client machine. So on my local machine, first all Ansible. We'll then write the inventory and the playbook and then simply deploy this playbook. On the client machine, there's just one thing that we need to do is that we need to check if the configurations that we mentioned in our playbook are made right. So we'll now begin our demo. This is my Oracle VirtualBox. Here I have my master system, which is the local machine, and this is the client machine. So let's have a look at these two machines. This is my client machine. The terminal is open right now. So the client machine terminal has a black background with white text, and the master machine terminal has a white background with black text, just so you can differentiate between the two. So we'll start at the master machine. The first thing to do is we need to install our Ansible. So yum install Ansible-y is the command to do so. So this might take some time. Yeah, so Ansible's installed. The next step, we go to our host file. So our host file here is basically the inventory. It's where you'll specify all your nodes. In our case, we just have one node. That's the path to your host file. As you'll see, everything here is commented. So just type in the group for your client nodes. So I'm going to name it Ansible Clients. And here we need to type the IP address of our client machine. So my client machine's IP address is 192.168.2.127. So before you come to this, it's advised that you check the IP address on your machine. The simple command for that is ifconfig. Now once you type the IP address, put a space, and here we need to mention the username and the password for our client. So I'll be logging in as the root user. So this is the password. And then the user. Which is root in my case. That's it. Now you can save this file. Just clear the screen. Next, we move on to our playbook. We need to write the playbook. So the extension for our playbook is YML, which stands for YAML. And as you can see here, I have already written my playbook, but I'll just explain to you how this is done. So a YAML file always begins with 3 dashes. This indicates the start of your YAML file. Now the first thing is you need to give a name to the entire playbook. So I have named it sample book. Host is basically where this would be executed. So as we saw earlier in our inventory, I mentioned client's group name as Ansible Clients. So we use the same name here. The remote user is the user you'll be using at your client. So in my case, that's root. And become true is basically to indicate that you need to set your privileges at root. So that's called a privilege escalation. Now a playbook consists of tasks. So we have here 3 tasks. The first task, I've named it to install HTTPD. So what we are doing here is we are installing our HTTPD package, which is basically the Apache server. And we are installing the most latest version of it. Hence the state value is latest. The next task is running HTTPD. So for the service, the name is HTTPD because that's the service we need to start running and the state is started. Our next task is creating content. So this is the part where we are creating our web page. So copy because this is the file that will be created at the client. The content will be welcome and the destination of the file will be var www.html index.html. As you know, this is like a default path that we use. to store all our HTML files. Now, as you can see here, there's quite a lot of indentation. And when it comes to YAML, although it's very simple to write and very easy to read, the indentation is very crucial. So the first dash here represents the highest stage, that is the name of the playbook, and all the dashes under tasks are slightly shifted towards the right. So if you have two dashes at the same location, they basically mean that they are siblings. So the priority would be the same. So to ensure that all your tasks are coming under the tasks label, make sure they are not directly under name. So yeah, that's pretty much it. So when you write your YAML file, the language is pretty simple, very readable. Indentations absolutely necessary. Make sure all your spaces are correctly placed. We can now save this file. Next thing we need to check if the syntax of our YAML file is absolutely right, because that's very crucial. So the command to check the syntax of the YAML file is Ansible playbook, the name of your playbook, syntax check. So we have no syntax errors, which is why the only output you receive is sample.yml, which is the name of your playbook. So our playbook is ready to be executed. The command to execute the playbook is Ansible playbook and the name of your playbook. So our playbook's executed, as you can see here, gathering facts. That's where all the facts of the node, that's the present state of the node, is collected and sent to the local machine. So it's basically to check that if the configuration changes that we are about to make is already made. So it's not made. We do not have the HTTPD package installed on our node. So this is the first change that's made. Also, if it's not installed, of course, it's not running. That's the second change that's made. So it's put into the running state. And a final task, which is create content, is under the OK state. This means that the content's already present in the client machine. So I made it this way so that you can at least see the different states that's present. So over here we have OK4, so 4 things are all fine. The facts are gathered, 2 things are changed, and 1 is already present. 2 changes are made. 0 clients are unreachable and 0 tasks have failed. So this is the documentation that I was referring to previously that Ansible provides automatically and is very useful, as you can see. So our next step, we need to just check on our client machine if all the changes that we desired are made. So let's move to our client. So this is my client machine. So to check this, since we are installing the HTTPD package and hosting a web page, the best way to do it is open your browser and type in localhost. So there you go. Your Apache server is installed and your web page is hosted. So that was very simple, wasn't it? If you have any doubts about the procedure or any other part of the tutorial, please post your doubts in the comment section below and we'll get back to you as soon as we see them.
We'll provide the overview of how and why you should be using Kubernetes. So why Kubernetes? Well, Kubernetes is really being built from allowing you to be able to have a more reliable infrastructure. The tool itself is designed to manage the containers you have within your network. It's very modular in architecture, which allows it to be very easy to be able to maintain and to be able to scale and meet the demands that your current customers are offering you today. The actual ability for you to be able to deploy and update software at scale is really at the heart and center of Kubernetes. It's really one of the reasons why Kubernetes was created, was to be able to scale up the deployment of software to tens of thousands of networks and servers within a data center. And then finally, when you start working with Kubernetes, really what you're doing is laying the foundation for building cloud native applications. applications. And part of this comes from the architecture and history of Kubernetes, which we'll get to in a little bit. But it's good to know that as you're using Kubernetes and containerized solutions, that you're really building out an infrastructure that's designed for cloud-centric solution delivery. So let's dig into what Kubernetes is. So the history of Kubernetes is that it was originally developed by Google. Google actually used the precursor to Kubernetes to manage and maintain the data structure and data infrastructure that they had within their network. They really liked it, and one of the big benefits that Google provided is that they converted their code into an open source program that they released as Kubernetes in 2014 and made it open source. This means that any company can use Kubernetes. There's no charge for it. All you have to do is know how to use the command lines to actually get up and running. The benefit of Kubernetes being open source is that most cloud providers now support Kubernetes. So whether you're using Microsoft Azure, you're using Google Cloud or AWS, you'll find that you can actually use Kubernetes. And Kubernetes at its core really helped eliminate manual processes. So it allowed for deploying and scaling your container-based solutions much more effortless within a cloud environment. So let's jump into the features of Kubernetes and why you'd want to be using it. And we have a number of features that we want to kind of step through. Again, the first thing that Kubernetes is a strong benefit of is that it eliminates those manual processes and allows you to automate them. The benefit you have from this is that you can then scale up your automation across your entire network. So whether you are managing 10 nodes within your network or whether you're managing 10,000, doesn't matter. You have the ability to scale. That's something you simply didn't have before. Kubernetes also will manage the actual containers themselves, including the security, the storage, and the networking within those containers. The great benefit of working with Kubernetes is that not only is it a cloud-centric solution, but it was really built from a core need of a secure solution. So security is at the heart and center of all the work you're doing, which really helps benefit any teams scaling out containers. Your Kubernetes environment will be constantly monitored so that when you have nodes that have your containers, the health of those nodes is being constantly communicated back to the Kubernetes environment so that the entire environment is always being managed and checked. So if you have any additional hosting and launching that needs to be done, Kubernetes will help you automate those manual processes. If something does go wrong, you can actually set up your Kubernetes environment to do an automatic rollback. Again, this is just allowing you to have that confidence that when you're deploying a solution that everything is going to work within that environment. And then finally, Kubernetes will allow you to mount and add the storage needed to run your apps. So whether you have storage such as a local SSD storage device physically on the hardware, or if you're connecting to storage via the cloud, Kubernetes will allow you to access the storage you need how you're accessing it. So let's look a little bit into the differences between Kubernetes and Docker Swarm. So if we just step back a little bit, Kubernetes and Docker often get connected with each other, largely because Kubernetes manages containers and Docker is really famous for creating the most popular container management solution, which is called Docker. If you're a developer, you're probably already using Docker today. So one of the things that Kubernetes is really, really good at is that it manages containers at scale, just massive volume of containers. Docker Swarm is Docker's alternative to Kubernetes. It's a tool that allows you to also manage large numbers of containers. There are differences between the two of them, and right now, without doubt, the most popular open source solution out there is Kubernetes from Google. It just has a massive community behind it, and the community really have embraced Kubernetes. Yes, the original product was developed by Google, but Google has been great stewards and they've allowed the community to drive the future evolution of the product. Docker Swarm is actually managed and developed by Docker. There is a smaller community, but it is also a very passionate community, and the reason being is that both products are actually pretty good and you just really kind of have to choose which one you want to go with. Without doubt, there is more customization and extensions built for Kubernetes simply because the community community is just so much bigger than the Docker Swarm community. But with that said, Docker Swarm is really easy to set up. So if you are used to working within the Docker environment, you'll be able to set up Docker Swarm very, very quickly. Whereas Kubernetes does require some heavy lifting to get up and running. Now, with that said, if you are using Microsoft Azure or Google Cloud, very often those environments will actually set up Kubernetes for you, so you don't have to do it, and you can actually then focus on writing the instructions to maintain your Kubernetes environment. Kubernetes has extremely high fault tolerance. Again, it's because Kubernetes has been road tested. The foundation for Kubernetes is based on managing sites such as Gmail, Google.com, YouTube. I mean, just incredibly robust environment compared to Docker Swarm, which has lower fault tolerance. And this really kind of leads into the final areas where Kubernetes does guarantee strong clusters management, just a really reliable environment. Docker Swarm, however, is able to take containers and deploy them into large clusters very, very quickly. Two interesting differences is that with Kubernetes, the load balancing is still manual, and it'll be interesting to watch how Kubernetes matures that skill set. In contrast, load balancing is automatic within Docker Swarm. So let's dig into the Kubernetes architecture and just kind of expose some of those key elements. If you're interested in actually having a very deep dive into Kubernetes architecture, we have already got another video, and we should have a link in the comments that you can select that will take you to that video as well. But this will provide you an overview as well. So the way that Kubernetes runs is that it uses nodes to actually manage all the individual hardware within a specific unit. And so a node is really a physical machine in a data center or a virtual machine. And when you're setting up an environment on a cloud environment such as Microsoft Azure or Google Cloud or AWS, Kubernetes will be managing the containers within that node. So it's important to know that Kubernetes itself doesn't work with the individual nodes, but actually works with the cluster as a whole. And why that's important is that it's a tool to manage your entire environment. It's not going to come down and manage the individual node itself. It's going to manage the entire environment. The actual control of data within a cluster, it's very, very flexible within Kubernetes. You can have local storage, such as an SSD card or a traditional local storage, or you can actually connect to the cloud and use cloud-based storage. And the benefit that cloud-based storage offers you is that you are increasingly moving your solution into more of a hardware-free environment, cloud-based architecture, where you're not reliant on a physical piece of hardware within your data center. And why that's important is that it gives you the opportunity to scale up your solutions much more effectively. So if you need to increase the hard drive space, you can do that very easily from the cloud, whereas local hardware is a little bit harder to manage. Great news, Kubernetes gives you both options to be able to choose from. And so the next layer down is the actual management of the application, and that's within a container. And as mentioned earlier, Docker is the most popular container solution out there. And again, if you're a developer, you're probably already using Docker, as it was a natural maturity from using a virtual machine. But Kubernetes itself will actually manage the containers that you have within your nodes. And so you have a collection of containers working together, and then you pull those together into what's called a pod. And what's great is Kubernetes will actually manage the health of that pod. So if a container or a pod fails, Kubernetes will automatically deploy out a replica so your entire environment can stay running and being efficient. And so the pods themselves will actually be managed by Kubernetes. And you really want to let Kubernetes do this, because it's allowing you to step away from the manual management of pods. Your environment is just going to be healthier relying on Kubernetes to do the actual management of all the pods you have out there. So you are able to allow access to, from services outside of your Kubernetes, and this is done through a process called ingress. And going back earlier, we talked about how security is a key part of all the work that goes into Kubernetes. And this is a great example of where you can use an external service but still have that layer of security that is vital for your solution. Because to be able to provide the ingress connection, Kubernetes requires an SSL connection, which automatically allows for a secure data transfer. Absolutely fantastic. So here we have an overview of the actual architecture. On the right-hand side, we have our nodes and the pods within our nodes, and within those pods are the containers. On the left-hand side, we have the master architecture, and the master architecture is the actual brains behind the work that you're doing. It's actually managing the schedules, the controllers for all of the nodes. And then at the bottom left-hand side, we have commands which are written on a local workstation, and those commands are pushed up to the master. So let's kind of dig a little bit further into the architecture of the master. So the master itself is comprised of a number of key components. Again, this is the tool that's going to manage your entire Kubernetes infrastructure. The key components that you have are the etcd, control manager, scheduler, API server, and the key four components are etcd, or the cluster store, the controller manager, the scheduler, and the API server. The cluster store is the tool where all the details of the work that you're doing is stored. It's going to manage the rules, it's going to manage all the instructions, and this is where you're going to post that information. The controller is actually going to then perform the tasks that are stored in the cluster store. And as you'd expect, the scheduler is the tool that actually controls when instructions and tasks are pushed out to all the pods and nodes within your network. And then finally, you have an API server which allows you to be able to control all the operations. The actual operations themselves are all instructions written as REST instructions, which allows you to take advantage of the security that has been built into REST. And so you end up with a worker-slave architecture, and slaves are all the different nodes and pods within your network. And so a pod itself will have one or more multiple containers, and then each container and then each pod will have a Docker container, a kubelet, and a Kubernetes proxy. And these are tools to allow you to communicate back up to the master layer. So the Docker is the actual container itself, and this is going to actually run your application. And the instructions here are to pull down the correct container from the Docker images that you have within your library. The kubelet is going to manage your containers, and your container instructions that will be deployed to the kubelet are going to be written in either YAML or JSON format. YAML is just great. If you haven't had a chance to start working with YAML, I certainly encourage you to do so. It's very easy to pick up. If you know any XML, you'll pick up YAML very quickly. And finally, the Kubernetes proxy is the tool that interacts with the master environment within the Kubernetes network and allows all the instructions that are pushed to the kubelet and to Docker to be able to perform effectively. So let's have a look at some of the companies using Kubernetes. There are a lot. And if you're doing any work today in the cloud, or even if you're just starting off and doing some simple work in the cloud, there's a really good chance that you are using Kubernetes. But some of the companies that you are probably not surprised are using Kubernetes are Spotify, SAP, eBay, and of course some of the big companies out there, Google with their entire network of solutions, and Microsoft with Office and their tools. So let's take a step into now let's have a look at a Kubernetes use case. And in this example, we're going to look at the New York Times and how they use Kubernetes to solve a problem that their IT department was struggling with. So when New York Times started working out of their data centers, their actual deployments were small and the applications were managed across VMs. But the problem is that as New York Times became more of a digital company, they started building more digital solutions. And at some point, they realized that what they needed to do was to embrace the cloud and move all their solutions to the cloud. However, their first step of using the cloud, and this is, I think, typical for a lot of companies, is that they treated the cloud hosted provider in the same way as they would with a data center. And at some point, they realized they had to take a change. And this is where the development team came in and they said, look, how about we stop thinking of our solutions as a data center, even though they're being run in Amazon, and start thinking of them as cloud-first solutions. And so what they proposed and what they ended up doing was using Google Cloud Platform with Kubernetes as a service to provide greater efficiency. And so by using Kubernetes, they had the following advantages. They're able to deliver solutions at a much faster speed, and in the world of digital content, speed is everything. They were able to reduce the time for deployment from minutes to seconds, and by doing this, they were able to increase the amount of time, uptime for the actual infrastructure. Updates began to be deployed independently and when required, so you didn't have to schedule an event when you do the deployment. It just happened. And there was a more unified approach to deployment from the engineering staff, which just made the whole solution more portable. So the fundamental end line for the New York Times is that by leveraging Kubernetes, they were able to automatically manage their deployments and scheduling of solutions instead of having to do solutions through a more traditional ticket-based system. It just really speed up the efficiency of the New York Times website. So let's finally kind of look into some of the important terminologies before we take our time to do a demo. So we have 6 terms that we're going to look through, and we'll let you read through these, but we have a cluster, which is a set of machines, physical or vertical, in which applications are managed and run. We have a node, that are the worker machines that run containerized applications and other workloads. There is the pod, which is within a node and is a group of containers that are deployed together on the same host. We have replication controllers, and a replication controller is used to define a pod's life cycle rather than to create the pods directly. We have a selector, which is an expression matched label to filter specific resources. Labels are key value pairs that are attached to objects such as pods. The key value pair or the label can be filtered, organized, and perform operations on resources. Replication sets define how many replicas of each pod will be running and managed when you want to either replace a pod when it dies. Annotation is a label with much larger data capacity. A name is a resource as it is identified. Volume is the directory in which data is accessible to a container. Namespaces provide additional qualification to a resource's name. And then finally, servers is an abstraction of a top-tier pods which provide a single IP address and DNS name by which the pods can be accessed. So at this time, what we want to do is take you through Kubernetes demo. It actually runs through some of these basic controls. So we're going to take you through a video of how to actually install Kubernetes and to use some of the basic instructions. So Kubernetes is the most widely used platform for container management. The first step is to actually install the necessary dependencies. So let's see if there's any updates first. So to check if there's any updates, we're going to use the command sudo apt-get update. We're going to enter in our password. And this looks like it's going to take a few minutes because we've got a few updates that need to be running. All right, we're done. All right, next we're going to write sudo apt-get install -y apt-transport-https, and this will install all of the dependencies we need to actually start installing the solutions needed for Kubernetes. All right, that was quick. Now we're going to put in the Docker dependency, and the way we do that is write the command sudo apt install docker.io. Got a typo, correct that quickly, and put in y, so for yes, and we continue. And that's going to take a while because we're going to download and install Docker off the internet, and it's quite a large installation. Now would be a good time to go get a cup of coffee because it'll take us about a minute to get this all done. Once we actually have Docker installed, we'll actually go ahead and we'll start Docker and enable Docker using our sudo commands. All right, so that's all done. So let's start to enable Docker. We're going to use sudo systemctl start Docker and sudo systemctl enable Docker. This will be quite quick. So the next step is to install all the components for Kubernetes, and we're going to install the curl command, and then kubelet, kubec, and then kubeadm. We're going to install all the necessary tools. We're going to do the curl command, kubelet, kubec-c2, and kubeadm. And so let's go ahead and put in the sudo apt-get install curl. We're going to get a prompt. We can say yes for that. And then after this, we'll go ahead and install Kubernetes. So the first, what we're going to do is we're going to actually put in the Kubernetes key. So that's going to be sudo curl-s, and then we have a long URL, which is https packages.cloudgoogle.com apt-doc apt-key.gpg sudo apt-key. There we go. Correct my typo there. Okay, now we have to go ahead and change permissions of a folder. So we do that with sudo chmod 777 /etc /apt/sources.list.d. All right, we're good. Okay, now you want to go ahead and open up your text editor, and we're going to make an actual edit, and we're going to create a simple file. And so what we're going to type in is the following command: db http apt-kubernetes.io /kubernetes-xenial main. And we're going to save this file in the etc folder, and then look for, and then apt, which is going to be down a little bit. And there we have it. And we're going to save it in the apt-get updates. And we're going to name this file as kubernetes.list. And we'll save that. And then we can close out the notepad and go back to the terminal window. And let's look and see if there are any updates again. So we're going to go ahead and run apt-get update, and it's going to run any updates from what we've created. And we want to check what's in the folder. And so we do cat /etc/apt/sources.list.d/kubernetes.list. And there we are. It shows what we have in that text file. And so we're going to go ahead and we're going to install kubelet, kubec2, and kubeadm. But first, we're going to have to initialize the master. I'm going to show you an error you would get if you were to install kubelet and the other files too quickly. You get the following error. All right, so we have installed kubelet, kubeadm, kubectl, and Kubernetes CNI. And so we're going to go ahead and use sudo swap-up -a. And now we're going to initialize the master node. And we're going to do that with sudo kubeadm init. And this will take a few minutes for it to initialize. All right, so that's all done. All right, so we're going to deploy the pod to a network. And we have two commands that we're going to use. We use sudo kubectl apply, and then we have a long path we have to type out, which is -f https raw githubs content.com Corios flannel master documentation kube-file.yml. What we have to do is we have to actually go ahead and deploy the nodes first. So we're going to do that by creating mkdir-p, and then we have $home-.cube. We'll create that new directory, and sudo cp-i, and then the path will be etc /kubernetes/admin.conf, and then $home/.cube.config. And then the final one will be sudo chown $open paren id-u close paren $open paren id/-g close paren $home/.cube/config. All right, now we're going to go ahead and deploy, and let's see. Oh, I think I have a typo in my command here. Yep. Oh, yeah, I did have a typo, and so I've got that incorrect now. So documentation is actually spelled with a T, not an S. And then we're going to go ahead and we're going to put in the next line, which is sudo kubectl apply -f, and then we're just going to change a little bit of the actual link here, and that runs great. And now we want to be able to see all of the pods that we have in our network. And so we're going to do that by writing the command sudo kubec tcl get pods all namespaces. And it should list all of our pods. We only have one. There we are. There's all of our content. Now we're going to, so there's only one node, so let's see what we have here. So we're going to use the command sudo kubec tl get nodes. There we are, just one node. So our final step is to actually go ahead and deploy a service. And so what we're going to go ahead is deploy the nginx service. And we're going to do that with the command sudo kubectl run -- image equals nginx. And we're going to put this into port 80. So it's going to be nginx -app -- port equals 80 -- environment env equals open quotes domain equals cluster close quotes. And we're going to write one more command, which is sudo kubectl expose deployment nginx -app -- port equals 80 -- name equals nginx -http. And once we've done this, we'll be able to then run the command to actually see our services. And there'll be quite a few of them. And our final command is sudo docker ps-a. There we are, quite a lot of lists, quite a lot of services listed. So there you are. That's the instructions on how to get Docker up and running, and with some basic commands. It's worth going through a few times to get right, but once you actually have the Kubernetes environment up and running, managing your Docker environment and containers, it's extremely powerful.
In this section, we're going to talk about what is cloud computing and how things were before AWS, and we're going to talk about what is AWS and the benefits of AWS and the products and services that Amazon offers as of now. And then finally, we're going to end this session with a project that is going to help us understand how to create a Jenkins build server for continuous integration. And in this project, we will learn about how to deploy and host Jenkins, an open source automation software predominantly used for CI/CD, otherwise continuous integration and continuous development. So what is cloud computing? Cloud computing is the on-demand delivery of compute resources through a cloud platform accessed via the internet, and it's also a pay-as-you-go service. Be it compute capacity or database or storage in cloud, we access them through the internet, and that too on a pay-as-you-go pricing model. Let's talk about how things were before